FastSense is all about monitoring the transition that we're now about to undertake from natural gas into hydrogen and biomethane. Our company effectively understands what's in your gas. We translate energy into value, underlining what the user gets at home to know what consumption you'll get. We do this through a few items. So firstly is that we have this semiconductor chip which knows how to detect multiple gases at the same time. It's a patent that we're actually a spin-off from Bar-Ilan University in Israel. I'm coming all the way from Israel. And then we have an actual embeddable or integrated section of the meter that goes on top of your meter or go inside of your meter. So what is the transition look like? So at the moment we are at 100% methane, and the journey to net zero will look something like this, where the methane will be slowly reduced in our pipelines. This is a pipeline that will effectively have biomethane and include hydrogen in it. So we use the current pipelines and gas to heat up our homes, to cook food. And this is effectively what the transition to net zero looks like. And if we reduce 20% if we implement 20% of hydrogen, it's like 6 million tonnes of CO2 emissions a year in the UK. But there's a problem to do with calorific value and how you actually measure and monitor the actual energy that you receive in terms of billing. Each one of these gases, shall I say, has a different billing mechanism. And we need to make sure that we understand individual gases that are being received through as a consumer. There's around 50 million metres in the UK, Italy and Germany. And obviously we want to make sure that we mitigate the volatility and we rely less on any external supply from Russia, for example. The problem in calorific value is that this is all of our homes at the moment. Okay, so I'll go back 1 second. So this is all of our homes at the moment. We receive natural gas. And okay, fine, it costs X amount of money. But as soon as we start injecting hydrogen in that process, we can see that if you live at one end of the scale, you're going to get closer, you're going to get more highly dense energy than somebody who's just receiving natural gas. Furthermore, if you are in a biomethane area, okay, then you're going to get more energy there. Now the problem is that energy that we're all consuming will effectively differ. So what it takes us, or takes me, to heat up my home or have a nice warm shower will take a little bit longer than somebody that's living closer to hydrogen injection point. Now that's a bit of a problem when it comes to billing, because we are effectively billed on an average flow rate, which basically means that depending where we live, that is our billing code, and that's an issue. So we effectively help reduce or get that billing a little bit more accurate. Because we're a multi-gas sensor, we know this is not going to happen straight away. So the here and now are the hard to decarbonise industries like steel, glass, cement, where they will be the first to adopt hydrogen, and again understand what's in their gas is essential. So they're going to probably look at methane, hydrogen, carbon dioxide, all these kind of wonderful gases. But what does it look like in today's day and age? So in today's day and age, we have manual sampling going on. Well, that's not real time, and it can take quite a while to manually take a sample from a gas and take it away. These are heavy chromatographs that are used in the industry, massive. You can't embed it anywhere. You can't put it anywhere that's small, tight. It's an issue, and they're tens of thousands of dollars. Average flow rate at the moment is the current metering system that I talked about before. But again, unless you're a smart meter, you're not getting data in real time. We come along, we've got billing, we've got calorific data, we're always online, we're a lot cheaper than any of these other solutions. The team is built up of 3 co-founders, myself, my name's David Souter, I'm kind of the CEO and in charge of the data interoperability. My partner is Guy Rahman, He is just finished his PhD in hydrogen sensors. And Professor David Zitun, who has many patents under his Department of Energy. He's all about energy storage. We've got a great advisory team. I think my time is almost up, so please, thank you very much. If you have any questions, this is Fun Sense.